Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, we are going to discuss one of the case studies which are relevant to the ground improvement techniques. So, as an understanding about the ground improvement technique in various ways, what kind of soil it is, what kind of construction we are going to do, what kind of desired properties is required for withstanding about that particular construction and long term and without any damage of that particular structures. Various characteristics are involved in that particular thing. So it depends upon the type of soil on those properties which are going to modify. So on which way they are going to modify and which technique gives the best practice for that particular construction work for getting the better results. So in this point of view, we have understand the jet grouting for Delhi Metro Rail. This is the one of the case study today we are going to understand in this lecture. So in this Delhi Metro, that too jet grouting technique. So the construction type is metro and the technique which we choose is jet grouting. So in this, what is meant by jet grouting? So what kind of technique it is? How it is helpful, in which way it is helpful for getting the desired properties of the soil for getting the metro construction. So these are all the parameters which are involved in this particular case study. So in this, what we understand that is, so in this jet grouting, different types are there. Different types of installation process is there. So based on the where we are going to construct the particular metro throughout the site, in between somewhere the soil properties are going to vary from place to place. It is a huge one. It is not within 1 kilometer, not in 3 kilometers or within some area. So it covers from somewhere to some other place. In between so many different kinds of geotechnical properties which we are understand throughout these kind of projects. Particularly where we require these kind of jet grouting, in that also various types are involved in that. What type we are going to adopt gives the best result for the particular condition. So in this lecture we understand, or in this case study, we understand all these parameters. Further, first we will recall about this jet grouting. So jet grouting, the name itself tells something jet. So it is one of the important ground improvement technique which we used. Why? Once we select the technique, once we understand the technique, first point what we have understand, what kind of properties involved in this particular technique. So what kind of property or characteristics are involved in that particular technique on basis of soil. So here jet grouting means stabilization and strengthening. So stabilize and strengthening. So here the jet grouting is a ground improvement technique which we use to stabilize and strengthening the soils. It involves, in this how it involves, how we are doing this jet grouting, whether it is injection process, whether it is mixing process, what kind of technique it is, how we are implementing this technique for getting the desired property of the soil. So in this, it involves the injection of high pressure jet of cementitious grout into ground to create inside soil-crete columns. So it may be some other, it depends upon the type of the project. Here for especially, we know jet grouting is a high pressure jet which are going to involve in the cementitious grout. So in this, those particular cementitious grout into the ground to create in situ soil-crete columns. So these columns improve what are the desired properties we required. Those are strength, stiffness, impermeability. What are they? It depends upon what we are providing for this jet grouting. So from these, based on these jet grouting, we are getting these desired properties of the project. So here, so it is jet grouting is a ground improvement technique is used to stabilize and strengthening the soil. It involves the injection of high pressure jet of cementitious grout. So it may be different types also. It depends upon the requirement. What kind of material we are choosing, it depends upon the material into the ground to create on-site soil-crete columns. So what these soil-crete columns are helpful for getting the desired properties, how we are doing all this process is involved in the jet grouting technique. So these columns, once we done with these columns improve the soil's mechanical properties such as strength, stiffness. These are all the soil properties which we are going to enhance or modified. Modifications done by using this jet grouting technique. Any kind of, what kind of project it is, this is the process which is involved. So in this jet grouting, it is a ground improvement technique which is stabilized. These are the two parameters which are going to enhance our whatever the desired properties we will get based on these soil-crete columns. So this is the little introduction about the jet grouting. Now, overview of this Delhi Metro project. Now we understand already we adopted this technique. We are talking about this particular technique only. So here, overall view in this, it is location, where it is located, what kind of soil it has available in that particular locality, what kind of soil it is, type of soil, what type of soil it is, type of soil, zone, whether it is belongs to earthquake zone, some sort of wind zone. So these are the various types, how there is a chance of this. So risk assessments from based on these assessments, risk assessments, and also water table, how much water table, from where it depth, how much depth the water table is available. These are all the parameters which are involved in this particular location. Once we have to understand these, all these kinds of location, how the location is involved in this particular conditions. So like that we have to understand. So based on this, we have to know about the what kind of material is involved in this particular thing. So here what we understand, how much distance the metro rail is covered, and from where to where the soil conditions are similar, and where it is going to change, the soil conditions are changing, what kind of changes we are observed. So these are all we have to understand using this location and based on the project. So in this, what we consider Delhi Metro underground stations. Delhi Metro underground and on-ground stations are there in the same line. So here we are concentrated in this particular case study underground stations. We are concentrated on the underground stations. So here the challenge, the construction of underground metro stations in densely populated urban areas with loose and sandy soils. So once we consider the metro rail line, because it depends upon the so many parameters, not only soil conditions. Once we know, only consider the soil conditions as parameter for finalize the where alignment of the Delhi Metro, it may not be give the same kind, because this alignment involves in the how many people we are using, where requirement is there as per public interest. These are the parameters involved. So according to that, we may construct in these loosey and sandy soils also. So this is the challenge involved in this particular project. So the proximity to existing buildings and infrastructure along with the need to prevent water ingress during excavation made soil stabilization is critical. So this challenge is involved in this metro underground stations in the Delhi locality. So what is the challenge involved in this? That is exactly the construction of underground metro stations in densely populated urban areas with loose and sandy soil. So it is public interest project. So here we have to, based on the as per the public interest, we are going to consider the alignment. So like that we have to understand the proximity to existing in this particular, but this is the challenge civil engineer is going to face because of these sandy and loosey soils we are going to construct the construction work. So in this so many difficulties are involved for existing that building, that infrastructure, along with to prevent the water whenever we are doing the excavation. So it depends upon so many challenges are involved in this particular conditions for construction work, any type of construction work. Now, in this challenges, what we split into different parameters, that is soil conditions, water table, urban constraints are the major challenges which we are faced in this particular condition. So in this soil conditions, the soil in parts of Delhi which is characterized by loosey sandy layers interpreted with silts and clays. Such soils are prone to settlement. So these kind of soil, the type of soil is loose and sandy layers and silts and sands. They are silts and clays. And what are the effects they are going to get once we done any type of construction? Settlement, affected bearing capacity of the soil. These are the parameters which we are going to modify for the withstand of the project. For getting the better results of the project, we have to modify these things in the soil. These are the parameters which are involved in these things. So now what we understand in these soil conditions, so it has low bearing capacity, and once we applied loads on the particular soil, it is going to settle down, and those are highly permeable, increasing risk of water ingress during the tunneling and excavation. Because of the underground metro trains means we have to provide tunneling also. So at the time of tunneling and excavation for required foundations and what are the remaining elements which we are going to construct, we face this water ingress also because of the silty and clayey soils, and also how much the water table depth is available is also one more challenge we are going to face in this particular construction work. So the high water table is same areas pose additional challenges. The presence of water could lead to be soil instability, erosion, potential flooding of excavation sites. So these are the things which we are going to face. These are the challenges. So that soil erosion, instability, whenever we are doing excavation, the flooding, the potential flooding will happen on these sites. These are the challenges we faced because of the high level water table in some areas. So now urban constraints. In urban areas, already it is density, the population density is more. So at the time of construction took place, because of the density populated urban areas with already some existing infrastructure is there, including roads, building and other utilities. So any ground movement or settlement could lead to the structural damages. It may affect the nearby structures also because of the soil, because of the type of the soil, it is very loose sandy layers which are present in that particular area. So already nearby, whenever we are consulting the alignment, nearby some structures are there, and any other infrastructures and roads and other public transportation systems are available, and some other infrastructure is there. So it may affect because of this kind of soil is there for constructing this. So these are the major challenges which we are faced in geotechnical point of view. As a civil engineer, we have to understand all these challenges and what are the remedies for getting the desired property and completion of the project. So in that particular point of view, so we have to understand the challenges first. So here we understand it is water kind, water table is high, soil erosion, strength point of view, and structural nearby structures are maybe affected. These are the things involved in this particular geotechnical point of view. So for these, all these characteristics we have to understand in different way. For this, we are going to implement this jet grouting technique. So in this, based on all these conditions, based on the overview and the geotechnical challenges, we have to choose which type of technique is suitable, that is jet grouting technique we choose. So in this jet grouting, what is the process involved, how we are implementing this jet grouting is very, very important in this particular case studies. In jet grouting process, drilling, jetting, column formation are the steps involved in this jet grouting. So here the drilling, a small diameter borehole will drill to the required depth. So the required depth is depends upon the elements, project elements where we are going to construct, what kind of construction we are doing, it depends upon the required depth of the drilling. So diameter is also depends upon the jet grouting. So here a small diameter borehole is drilled to required depth. So now the jetting, a high pressure jet of grout. So the cement water mixture. So the cement water mixture, the cement, what kind of cement we are considering it depending upon the design consideration, which is injected into the ground through the drill rod. The jet cuts and mixes the on-site soil with the grout, creating a column that is nothing but the soilcrete. So in this on-site, we are doing this jetting. So it depends upon the condition. So based on the elements, we are going to do this kind of jetting process. Here this column formation, the drill rod is slowly withdrawn. We are going to withdraw this drill rod slowly and rotate continuous to ensure uniform grout distribution, forming a continuous column. So once we ensure with these uniform grout distribution and forming a continuous column, so this just process is completed. Now in this, first we done with our process, we are drilling, after that we are going to jetting, the required mix is using, and we are creating a column of the soilcrete. And this, once the drill, whatever the column formation is done, we are slowly removing the drill and rotating continuously once we assure the uniform grout distribution and forming these continuous column. Now in this, different types of grouts, already we talked about this, it depends upon the what type requirement of the project. So choose type of jet is depends upon the what kind of soil it is, what kind of requirement it is, it depends upon the we are going to choose. So in single fluid system, only grout is injected at high pressure. So we may require, as per the project requirement, it requires only high pressure. It means only single fluid grout, it is nothing but the only grout is injected at high pressure. Double fluid system. So grout and air are injected simultaneously, enhancing the soil cutting and mixing. So whenever the project demands or the elements, they are demanding the soil cutting and mixing for enhancing these conditions. So we are going to choose this type, that is the double fluid system. It is nothing but grout and air are injected simultaneously. And the next one is triple fluid system. So whenever we require the maximum soil cutting and mixing efficiency, such a type we are choose this triple fluid system. It is nothing but the grout, air and water are injected, providing maximum soil cutting and mixing efficiency. So in that such type we are going to choose this triple fluid system. So depends upon the condition we are going to choose. Based on the conditions we are going to choose the type of grouting. Type of grouting. So in this column arrangements, columns were arranged in overlapping patterns to create continuous barriers or block forms depending on the design requirements. So it depends upon the design requirements how we are arranging this column arrangement, whether in the condition of overlapping patterns to create continuous barriers or block formation depending upon these designs. This helped in forming a watertight curtain and around the excavation area. So here this helped in forming watertight curtain around the excavation area. So here it is help. So this kind of arrangement is depends upon the design requirements. Based on the design requirements, we are going to consider all these parameters. So according to that, we are going to choose the type of jet grouting also. And next move on to these design considerations. Column diameter, depth of the column, grout mix design. These are the major design considerations where we consider these. So in column diameter, typically between 1 to 3 meters depending upon the soil conditions and the project requirement. According to that, we are going to choose the column diameter which is in between 1 to 3 meters. Depth of the column is also designed to extended below the excavation level to ensure complete stabilization and cut off groundwater. And the ground mix design, the grout mixer was designed to achieve the desired strength and permeability characteristic, typically a mix of cement and water with additives like various properties which are going to enhance these using these kind of additives and additions for these mixes. So in this ground mix design, which is desired for how we are getting these desired property. For getting the desired property only we are going to choose. For getting the desired strength and desired properties are desired properties. Strength are desired properties. According to that, we are going to choose the mix. So typically cement and water, how much mix percentage is also depends upon how much proportion. Mix proportion is also depends upon the project requirement and the soil conditions. So according to that only, then only we are going to grout mix work design to get the desired properties and what kind of additives gives the what kind of result. So once we required more strength and okay, it's more moderate means we are considering a different mix proportion. So high strength means we choose the different mix proportions, this cement and water. So like that, this mortar what we mixer the between for getting the grout mix design is very important to get the desired mix. So in this, what kind of material we are choosing, how it is helps and what kind of properties it has and how it helps to get the desired properties. These are all the parameters. And also one more important parameter in that, mix proportion is also plays a role in grout mix design. So 1:2 ratios, 1:3 ratios, like that. The mix proportions is also important to getting the desired properties. So without losing, and also in this cost economical point of view also we have to think and then only we are finalize the grout mix. So these are the desired considers which are based on the soil conditions and also the project properties, based on the what kind of stabilization we required and what kind of mix design gives the desired property. These are the things we have to understand in this design consideration. Where we are applying these into the Delhi Metro project, stabilization of excavation site, water control, safety and structural integrity are the applications where we use this jet grouting. This technique we are using for this stabilization of excavation and water control, safety and the structural integrity. In this stabilization of excavation site, jet grouting was primarily used to stabilize the soil around the station boxes and tunnel portals. The columns created a solid and impermeable block that supported the excavation and preventing water ingress. So in this, jet grouting was primarily used to stabilize the soil around station boxes and tunnel ports. So in this, the column created a solid and impermeable block. So this, because of this jet grouting, we are getting this kind of impermeable block that supported excavation and also to prevent the water into this excavation. For this is the one of the major application from the jet grouting technique for this kind of metro projects. Into that to underground scenario. In the underground scenario, water control is very important. That too highly water table is available. So in this jet grouting process, it created an impermeable barrier that effectively controls the groundwater during the excavation. So how it control, how much this impermeable barrier is effectively is depends upon the design consideration as well as the mixed proportions which are involved in this jet grouting process. So in this, after that, then only it is going to create this much of impermeable barrier that effectively control the groundwater during the excavation. This was critical in preventing flood and maintaining dry working condition for construction crews also. So it is very important for getting these kind, then only the dry conditions are helpful for getting the construction. And also, this is important in safety and structural integrity. By reinforcing the soil, the jet grouting minimized the risk of ground settlement and ensured the structural integrity of the surrounding buildings and infrastructure. This was particularly important in densely built up areas where any movement could have significant consequence. So whenever we are doing densely built up areas, so it is very important whenever any kind of consequences are the damages are more in so many aspects. So by reinforcing this particular soil, we require this reinforcement of the soil using this kind of jet grouting technique. It is minimized the risk of the settlement. So and ensure the structural integrity and the surrounding buildings and also the infrastructure. And these challenges and solutions, what we understand from these. So uniform grouting. So we face the settlement. It means the different soil conditions acts in different conditions and they are having different kinds of settlements. So using these kind of uniform grouting, achieving uniform soil columns, soil-crete columns in variable soil conditions. So once we achieving this uniform soil-crete condition, because it may be uncertainty is there. So once we get these uniform soil-crete columns, then the continuous monitoring and adjustments of jetting parameters is helpful for uniform grouting. Once this is the way we reduce these kind of challenges. So that is important in this particular aspects. So achieving uniform soil-crete columns in variable soil conditions was challenging. So this continuous monitoring and adjustments of these jet parameters, pressure, grout, flow rate were necessary to maintain consistency. Now quality control, the quality of the soil-crete columns was ensured through rigorous testing. So we have to done this testing including coring and laboratory analysis of sample. So once then only we understand this quality control. So we have to conduct the tests. Once we understand it. So before these application of the jet grouting, what kind of soil condition it is there? So after that, what kind of soil conditions are there that gives the quality, that gives the analysis of the understanding about the soil-crete columns. So including coring and a laboratory analysis of samples. So real-time monitoring of grout pressure and flow rates help in maintaining the quality. So whenever we are monitoring this grout pressure and flow rates, monitoring real time, so that gives the help in maintaining the quality. In these environmental considerations, proper disposal of spoil material and management of grout slurry was essential to minimize the environmental impact effect. Otherwise, it impacts environmental very badly. So the proper management, if not done, impacts this environment. This may causes other kind of, we may face different kind of situations because of the huge density area it is, and it is also urbanized. So in these measures were taken to prevent the contamination of groundwater and soil during the grouting process. So this is also one of the environmental concerns which we have to understand to prevent the contamination of ground and soil during the grouting process. These are the considerations. What are the various considerations which are involved in this particular challenges, and these are the solutions we are understanding from this grouting technique. Now, what are the outcomes and impacts? So, till now, these are the various challenges, these kind of applications based on this technique, and in that various challenges we understand now what is the impact, what is the outcome. So, once the successful of soil stabilization, prevention of water regress, structural safety are the major outcomes what we get from this using this jet grouting technique for these kind of soils. Jet grouting is the ground improvement technique. Silt and clays are the type of the soil. So once we choose this technique, these are the outcomes and impact for the metro project, for desired project. So here, the successful soil stabilization. The use of jet grouting allowed for the safe excavation of underground stations with minimal impact on the surrounding urban environment. So this is the one of the important and success point for this outcome. So we use this jet grouting that is allowed safe excavation of underground stations with minimal impact of the surroundings because of it's the urban culture it is there. So the stabilized soil provided a solid foundation for further construction activities. So the stabilized soils provided a solid foundation for further construction activities. And the next important one is the prevention of water ingress. So the impermeable soil-crete columns effectively prevented groundwater from entering into the excavation sites, ensuring a dry and safe working environment for construction crews. Structural safety. The technique minimized ground settlement, protecting nearby structures from potential damage. This was particularly critical given by the proximity to the existing buildings and infrastructure. These are the major outcomes and impacts which we are going to understand in this. Site-specific design, real-time monitoring, environmental management are the lessons we learned. These are the best practices for any kind of technique. For this particular technique, once the site-specific design is very, very important, we have different types of jet groutings. For replacing the jet grouting techniques are also there in ground improvement techniques. So we choose these kind of, the choosing of the right technique is the very, very one of the best practice and important to learn from these kind of case studies. So the success of jet grouting depends upon through understanding of the site specific soil condition. So we have to understand technique, what kind of ground improvement technique is suitable for the site conditions. That gives the successness of the success. That is the best practice, which is we understand from the understanding the various case studies, and based on the experience we will get these. So and after that also from the technique, once we choose the technique, in that also involved various types are involved. It may involve, may not, it may or may not be involved. Based on these types also choose the right one. Then only we will get the desired properties. So like this we have to understand the overall thing. So here the jet grouting is the technique for these kind of metro project underground, that too in urban regions. So this is the depends upon throughout the site specific condition. This customized grouting, it depends upon the type of the grouts or various types are we are going to choose, depends upon the requirement of the project. So these customized grouting, in this various materials also involved, mixed design proportions involved, all the various parameters are involved. So now the customized grouting parameters and column designs are essential for effective stabilization. Here also the column design, the diameter and how much depth, these are depends upon the site conditions. In that, according to that we are going to choose. So that gives the effective soil stabilization, that gives the desired properties or required property. And real-time monitoring, continuous monitoring during the grouting process is crucial to ensure the quality and consistency of the soil-crete columns. Adjustments based on real-time data help in addressing any issues promptly. So once we understand the various case studies in that best practices for that particular case studies, this real-time monitoring is also understand very quickly. In this particular jet grouting, the continuous monitoring during this grouting process itself, it is crucial to assure the quality and consistency of the getting the soil crete columns. So then only we will understand how the process is working, and any adjustments based on the real-time data help in addressing any issues. So like that we are going to understand this particular scenarios. In this environmental management, proper handling and disposal of grout and spoil materials are necessary to prevent environment contamination. Implementing best practices in waste management minimizes the project's environment footprint. So in this relevance to Indian infrastructure project, so in this urban infrastructure, jet grouting is particularly relevant for the infrastructure projects like in urban areas with challenging soil conditions such as Delhi, Kolkata and Bangalore. Its ability to stabilize the soils and control groundwater make it ideal for underground construction in densely populated cities. So the success of jet grouting in the Delhi Metro project has set a precedent for its use in other major infrastructure projects across India. It's likely to be employed in upcoming metro expansions, underground utilities and deep excavation projects. So in this, jet grouting played a critical role in the success of Delhi Metro underground station, ensuring the safe and stable construction in challenging soil conditions. The techniques adaptability to verifying the soil types and effectiveness in controlling groundwater make it an invaluable tool for urban infrastructure development in India. So in this, what we understand till now, based on the jet grouting, what kind of desired properties we will get, how to choose from various types of the jet groutings available, from that how to choose on which basis we are choosing the type of the jet grout, and how we are going to design these based on various consideration mixed proportions. After that, how it is that background, how we are overviewing in various ways we will see in the continuation of this lecture. So here, what is the background and context? The Delhi Metro is one of the largest and most advanced urban transit system. So its extensive network includes underground and elevated sections. The underground sections in particularly, whenever the significant challenges to do the complex urban environment and various soil conditions, we will check it in this background. So here the significance of this underground construction, the decision to build underground stations were driven by need to reduce the surface level congestion on a densely populated area. So underground construction also helps preserve existing infrastructure and minimize the disruption to the city's day-to-day activities. So because of that reason, we are going to choose this underground. Why we choose underground Delhi Metro? This is the one of the reason. Now in this, what are the geotechnical investigations and site assessments? So for considering this jet grouting technique, what are the various things involved in this? That is the geotechnical investigation and site assessment, soil profile analysis, hydrological conditions. These are the things we are going to investigate in this. What are the challenges identified? So in this geotechnical investigations and site assessment, we done this soil profile analysis. We analyzed the soil in all possible ways. So a comprehensive geotechnical investigation was conducted to assess the soil profile along the proposed metro line. So the analysis relevant the presence of loosey, sandy soils with low shear strength, and those are silt and clay layers. These soils were, make sure we are facing the settlement issue, and it is highly permeable, and it is conventional excavation without prior stabilization is unsuitable. These are the challenges which we understand from based on this soil profile analysis. How we choose based on this is the background. Soil profile analysis. So once we understand the type of the soil, what kind of challenges we are going to understand. In hydrogeological condition, the water table in parts of Delhi is relatively shallow, increasing the risk of water ingress during the construction. So the presence of water in loose sandy soils can lead to quicksand conditions, further complicating the excavation efforts. So these are the challenges what we identified. So in this settlement control, the need to control ground settlement was critical, especially in areas with existing buildings and infrastructure. And also the water regress, preventing water regress into excavation site was essentially to ensure safe and efficient construction. In this structural integrity, maintaining the structural integrity of the near buildings as roads as a key concern. These are the challenges which we identified. So in this, the jet grouting, we decided to go through with the jet grouting. What are the details involved in this? So we simply understand it. Previously understanding theoretically, now we understand what are the parameters involved in this particular case study. So here the jet pressure typically range from 400 to 600 bar, depend upon the soil type. The jet pressure purely depends upon the soil type and required column diameter. High pressure ensured effective soil cutting and mixing. And next move on to the grout flow rate, on which once we understand this grout flow rate is also plays a role to control to achieve the desired soil grout mix ratio, usually between 40 to 120 liters per minute. How much soil grout once the mix proportion is be done based on the design considerations. So how much flow it is going to get, it depends upon the 40 to 120 liters per minute. So the withdrawal rate, once we assure with the soilcrete columns, the uniformity we will achieve, and what are the desired properties we will get, we achieved once. We withdraw this drill rod after we assure with this continuous effect of that particular one. Now the drill rod withdrawal rate was carefully calibrated to ensure uniform column formation, typically ranging from 1 to 5 centimeters per minute. So like that we have to understand these numericals. Now the soilcrete properties. Strength, permeability. So are the properties which we are going to understand in this soilcrete. So the unconfined compressive strength of the soilcrete column was designed to extend the natural soil strength by several times, typically ranging from 2 to 5 MPa. Move on to the permeability point of view. The permeability of soilcrete was significantly reduced, typically to the values less than 10 to the power of minus 6 centimeters per second, effectively creating a barrier against groundwater. In execution steps, pilot testing before full-scale implementation, pilot test was conducted to fine-tune the jet grouting parameters and ensure that the columns met the design specifications. In real-time monitoring, sensors and instrumentations were installed to monitor the pressure, flow rates and column formation in real time. This allowed for immediate adjustments if inconsistency were detected. In site-specific applications and challenges, so what are the, in that particular site-specific applications and challenges? So in the station-specific consideration, each underground station presents unique challenges based on its location and surrounding environment. For example, stations near rivers or low-lying areas required more extensive jet grouting to account for high groundwater levels. So it depends upon the soil conditions and where it is placed. So coordination with the tunnel boring mechanism, mission operations. So jet grouting was often coordinated with the tunnel boring mission operates to ensure that the soil around tunnel ports were adequately stabilized before tunneling commencement. This minimized the risk of tunnel boring mission related ground movement or settlement. These are the background things which we are understand. In environment and urban, it is the urban area. So what kind of environmental and urban impacts we'll face? How we manage all these parameters? So in this noise and vibration, because of the high pressure jet grouting process creates noise and vibration. It is urban area, it is highly densely populated area. So it is disturbances will happen. So these mitigation measures including scheduling work during off-peak hours and using noise barriers to minimize these disruption. So where we have to done when that particular time, because of the urbanization and the nearby so many works and so many disturbances are there. So whenever we are doing, we have to choose the hours where we are doing this high pressure jet grouting, and also use noise barriers to minimize this these kind of disturbance because of the urban impact. In this spoil management, the process of generate significant amount of spoil material which required careful handling and disposal to prevent the environmental contamination. This case-specific outcomes and elevations, performance monitoring, comparison with other techniques. So in this post-construction monitoring was conducted to evaluate the performance of jet grouting. This includes settlement, surveys, groundwater level, monitoring, and strength testing of soil creating samples. So after construction, we are going to monitor and we know about the performance. We have done the tests and we will understand these parameters. Strength testing and some soil crete samples we will collect. Once the effectiveness of jet grouting was compared with other ground improvement techniques like diaphragm walls and deep soil mixing, the jet grouting was found to be adaptable to verifying soil conditions encountered in the Delhi, providing superior settlement control and water cutoff. Because for any kind of challenges, we may understand different kinds of types techniques may be available. In that, which one is suitable is the different parameter we have to understand. In this, jet grouting is the best practice for these kind of soil conditions. Based on the soil conditions and the project type, according to then only we choose the best technique. So this is the comparison. So we may choose in this kind of soil condition, we may choose deep soil mixing also, but jet grouting was found more adaptable for these particular conditions. And although jet grouting is relatively expensive, its ability to stabilize soils quickly and effectively reduce overall project delays and risk, making it a cost-effective solution in long run. Whenever we consider in short period, within the short time, it may be look like costly. But once we understand, we go through all the things, it may be costly at that particular time. Once over the period, because of the how much ability to get the stability of soils very quickly within the timeline, and it reduce the overall project delays and risk. So it make it cost effective solution in the long run. So that is also we have to understand. In these groundwater management, contaminant control are the important environmental factors which we are discussed in this particular metro project. So the impact of jet grouting on local groundwater flow was carefully managed. The impermeable columns altered the natural flow of groundwater, necessitating a detailed study to ensure the nearby wells and aquifers were not adversely affected. So the groundwater management, we have to understand the nearby the water tables and any aquifers that gives the better these ground management. The impact of jet grouting on local area flows very carefully managed. Once we understand what are the columns we are going to choose and alter the natural flow of groundwater in this detailing to ensure about the nearby wells and aquifers. So this is also one of the environmental factor which we have to consider. And containment control. Special care was taken in areas with contaminated soils to prevent spread of pollutants. So the grout mix was adjusted to encapsulate contaminants within the soil crete columns, preventing leaching into the surrounding environment. And in the long-term environmental impact, the long-term durability of soil crete columns were evaluated with studies indicating minimal degradation over the time. So this ensured that the ground improvement would remain effective for the lifespan of the metro infrastructure, reducing need for the further interventions. In these advanced topics which we are going to understand in this innovation in jet grouting, comparative case studies, risk management. In this, recent advantages in jet grouting technology such as the use of polymer modified grouts and real-time 3D monitoring systems were explored. These innovations offer improved performance and greater control over the grouting process. Comparative studies, a comparison with other international metro projects such as the various different types of Newark, London, where jet grouting was also used, providing a global perspective on this technical effectiveness. The risk management strategies employed during the Delhi Metro project was discussed in detail, including unexpected soil conditions or equipment failures. So these are the various parameters which are involved in this particular thing. So finally, it depends upon the condition, projects we are going to choose and what kind of effects are getting from this as per the ground improvement point of view in this particular case study. So we will see in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.